Alright, this is ACT Prep Advanced 2. This is going to be the second part to that. Trying to make these videos a little bit smaller so you don't die of boredom. Probability, just to remind you what probability is. Probability can be found by taking the probability of an event happening. Can be done by taking a fraction in which the numerator is the number of favorable outcomes, good outcomes if you will, divided by the total number of outcomes. Quick example, let's say that you want to know the probability of you rolling a die and that die coming up a 4. How many good outcomes are there? There's only one. There's only one 4 on a die. Total outcomes, if you roll a die, it could come up in any of 6 sides rolling up, so it's 1 out of 6. Sample space and event have to do with probability. Sample space means all the possible outcomes that could come from whatever you're doing. So if you're flipping a coin, sample space would be head and a tail. It's the only two things that can happen. If you are rolling a die, one die, a sample space would be like a 1, 2, 3, 4, 5, and a 6. An event is what you want to happen, what you're trying to get to happen. For example, an event would be a 4 happening, or event would be that you're getting ahead if you flip a coin. So sample space is all the different possibilities, and an event is one possibility. All right, let's do an example. Number 9, if 2 standard dice are rolled simultaneously, what is the probability that the total rolled value will be greater than 9? So this is asking for the probability. If it's greater than 9, it means that you're going to get a 10, an 11, or a 12. Well, this problem is a little simpler than you might think, and it's not as simple as some might think. Let's figure out how many different ways can you get a 10 on a die. You could have, let's see, a 1 and a 9, it won't work because the die only goes to 6. 2 and an 8 doesn't work. 3 and a 7 doesn't work. There's no 7. 4 and a 6. So you could get a combination of 4 and 6. Let me write this differently. Let me write 4 and a 6. Let's do an ordered pair. Let's do it like this. That's one possibility. Or you could get a 6 and a 4. Those are two different things. Or you could get a 5 and a 5. 3 different ways you could get a 10 on a die, on 2 die. How many different ways can you get an 11? You can get an 11 if you roll a 5 and a 6, or if you roll a 6 and a 5. How many different ways can you get a 12? Only one, if you get 2 6s. So the reason we wrote those down is so we know how many favorable outcomes are there. There is 6 favorable outcomes. You got 3 here, 2 here, and 1 here. What's the total outcomes? Well, if you roll a die once, you have 6 different possibilities. If you roll it a second time, you have 6 possibilities. If you multiply those together, that means there are 36 different possibilities. So the probability of getting a number that's greater than 9 is 6 out of 36, which reduces to 1/6. There are joint events. So 2 things happening, and one possibility is that these things that are happening are independent of each other. If 2 events are independent, it means one event has no bearing on the outcome of the second event. One event does not affect the other event. So when that happens, we can use the product rule. Here's what the product rule is. The product rule is if you're trying to find the probability that A and B are happening, So two different things. You simply find the probability of A happen, and you multiply it by the probability of B happening. Let me bring this down here. This only works when you have independent events. So let's look at an example. Maureen is playing a board game with rules that require her to roll a single die twice and then move her token that many spaces. What is the probability for a single turn that she rolls 2 3s? So we're looking for the probability that she gets a 3 on her first turn, on the first die I should say, and a 3 on the second one. According to the product rule, this is the same as saying what's the probability of her getting a 3 times what's the probability of her getting a 3, which is actually simple. On a die, there's only 1 3. There are 6 possibilities on a die. So there's 1 in a 6 chance she's going to get a 3. So what's the chances that the other die is a 3? Also 1 out of 6. So that means there is a 1 in 36 chance of her getting a 3 and a 3. Not bloody likely. All right, number 11. What is the probability that the product of one element chosen at random from the set 1, 2, 3 and one element chosen from the set 4, 5, 6 will be odd? The product of those. Well, I need to first figure out what my sample space is. So I'm going to just make a little table. Got the one set across the top, the other set on the left here. I'm going to find each of these products. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. 1 times 5 is 5, 5 times 2 is 10, 5 times 3 is 15. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. So to find the probability that we get an odd product, we need the favorable outcomes. How many of these products are odd? Well, it looks like there's only 2. Color-coded them for your viewing pleasure. How many possible outcomes are there for this? Well, there is 3, 6, 9 outcomes. So the probability of getting an odd product is 2 out of 9. Done. Contingent events. Contingent event is when one outcome affects another. And when one outcome affects another, you have to change the way you think about the problem. You can still use the product rule, but the second factor that you have that you're multiplying is going to be a little bit different than if they were independent events. Best way to explain it is with an example. If a jar contains 3 red marbles and 7 black marbles, I'm just going to write that down, 3 red, 7 black. What is the probability that 2 red marbles will be drawn from the jar on the first 2 random draws without replacing the first marble drawn? So we're trying to find the probability of getting a red and then a red. So let's look at the first one. What's the probability of getting a red? Well, there are 3 red in the container, and there are a total of 10 marbles in the container. So it's 3 out of 10. Now at this point, we're assuming that we got the desired result. We pulled a red out. So how many reds are left in the jar? Only 2. So if we already pulled one out, it means there's only 9 marbles total left in the jar. So it's 3 out of 10 over 2 out of 9. This just needs simplified. We can divide both 3 and 9 by 3. We can divide 10 and 2 by 5. So if you multiply the top numbers and the bottom numbers, you get 1 out of 15.